Good morning. Was that funny? Let's try again. Good morning. Thank you. All right. Awake? It's a little too early for a Saturday morning. Okay. My name is Arun Gupta, and I work for Oracle. I have a popular blog, sometimes controversial as well, which is all right. And just like everybody, I got a Twitter handle. So I'll share my slides on my blog, so you can get all the material over there. And we can keep the session interactive. So my goal would be, I have about 50 odd slides. I don't mean to run through all the slides. I've been told I have only 30 minutes to actually present the material. So what I'll do is I'll try to cover highlights, and then I'll also try to show a demo as well, just to kind of give you a basic idea of how the whole platform is evolving. And then we can have an interactive Q&A, all right? This is pretty much the only marketing/legal slide. The idea is, this is a technical presentation. Don't make your business decision based upon the dates that I quote here. The dates are only indicative. They're not definitive. They can change. Most likely will change. So just to give you a quick idea of Java EE 6 platform. How many of you are using Java EE 6 today? Wow, almost 90% of you. Lovely. That's I love to see. Wow. Okay. So the platform itself was released over 2 years ago, December of 2009, effectively. And the top features of the do it up like this. Okay. All right. Oh. So there have been 40 million downloads. There have been 40 million plus downloads of the platform. Oh, screw it. I'll speak loud. This is too bothersome. All right. So there have been 40 million plus downloads of the platform to date, and then I'm only talking about GlassFish, which is a reference implementation of it. So huge momentum around Java EE platform. Is the fastest implementation of a Java EE release. In less than 2 years, there are 14 compliant application servers. So you write your applications to the Java EE API, and those can run on any of those 14 compliant application servers. So be it the two application servers from Oracle, which is GlassFish and WebLogic, which are both Java EE 6 compliant, or Red Hat JBoss, or Fujitsu, or a couple of application servers from Apache or IBM. You write your applications to the Java EE 6 API, and then you can run them on any of those application servers, providing true portability, essentially. Now, in terms of the key features of the Java EE 6 platform itself, there are several, but these are sort of the top 10. And if I want to highlight some of them, the first one really I want to talk about is CDI, which gives you type-safe dependency injection. Unlike those proprietary frameworks, it's not string-based. It's giving you a type-safe dependency injection. That means all the information that you require for dependency injection is available in the Java type system itself. EJBs are extremely simplified. How many of you have used EJBs in J2EE 1.234 timeframe? Keep your hands up. How many of you still like it? Exactly. For me, it was very confusing, and I used to hate it. Why so many classes? Why deployment descriptors? Ugly, really ugly. Now with Java EE 6, EJBs are overly simplified. Just one single class, a POJO class, which is a plain old Java object. Just one class and one annotation. That's it. No deployment descriptors, and it could be very easily packaged in a WAR file. So we have overly simplified EJBs. So I think it's really making big difference as part of the Java EE 6 platform. Now we also have made the deployment descriptors optional in most of the cases, so you don't need deployment descriptors. All the information typically required in a deployment descriptor actually goes as part of the annotation. Again, Java type safety and annotations, all the latest language features are being leveraged over there. JSF are also standardizing on facelets. Typically in a Java Server Faces page, you will use JSP as your front-end page. Well, JSP, by definition, you can have your entire model and view and controller right there itself. One JSP could be your entire website effectively. With Facelets, you can have only XHTML and CSS as your view. Your model and controller live back in the backing beans. And that backing bean, again, which used to be JSF managed bean, no longer required. You can directly have an EJB injected in your JSF page. So that makes a big difference. So now Java EE6 provides a whole lot of APIs which are very useful, very effective, very clean, simple, easy to use, working on a variety of application servers. What's happening today? Cloud is no longer a facade or something that's coming in the future. Cloud is real, it's happening today. But what's happening in the landscape today? So think about infrastructure as a service, platform as a service, software as a service. In all of those three services, platforms, there are a bunch of offerings that are available today. But each of them is a proprietary offering. They give you a vendor lock-in. What that means is, if you start using Amazon Web Services today, now you take EC2, S3, and all of those, you start building your applications using Amazon APIs. But then you're using Amazon APIs only. You're logged in there. You cannot port to another cloud service. Start using Google App Engine. Same thing. Start deploying your applications to Cloud Foundry or Salesforce. So whatever APIs are given by those folks, which is typically a single company, not backed by multiple companies effectively, then your APIs are logged into those. Now that goes against the philosophy of Java EE. Java EE is all about, all those companies like Oracle, IBM, Red Hat, Apache working together, providing a set of APIs that run on a variety of servers, giving you the choice of your application server. So what we're doing is we are taking the Java EE platform into the cloud itself. What does that mean? Going forward, that means the focus of Java EE 7 is going to be in three primary pillars, so to say. First is, of course, cloud. By cloud, we really mean automatic service provisioning. Think about when you take a WAR file and you want to deploy your WAR file to a Java EE application server. What do? You say, hey, I'm going to provision and initialize my mail service. I'm going to provision and initialize my messaging service, then my database server, or then my application server. And by provisioning and initializing, it could be local, it could be on a cloud, it could be in your IT department, all of that. And then you finally say, oh, now I'm ready to deploy my WAR file. So your goal was to deploy the WAR file, but you have to go through all of that provisioning and initializing by yourself. Java EE 7 will simplify that in the sense that you just take the WAR file, you give it to a Java EE 7 container, it will automatically provision and initialize those services for you. That's one part of it. Second part of it being dynamic scaling, in the sense you deploy a WAR file and you define certain metrics. If there are more than 200 concurrent sessions, automatically scale up a server. If the memory usage is less than 20% across my cluster, automatically scale down a server. Things like that. So you will be able to define metrics, certain predefined, and you can of course define custom metrics. Based upon those metrics, triggers would be issued, which would actually take some decisions, scale up or scale down. Could be completely dynamic. Multi-tenancy is a big aspect of the cloud. So that's sort of the focus in the cloud area. Now, JDK 8 is also focusing on the modularity part of it, which would allow you to define an application in a modular sense. So if you're building, for example, a web services application, you may not care about the CORBA part of it or the JMS part of it. So you could say, my application really depends upon so-and-so module. Pick those two modules, your disk footprint, memory footprint, stay very low, and you go with that. Now Java EE 7 or 8 builds upon JDK 8, and then that's going to leverage that modularity. So for example, you could define, here is my Java EE application, and it requires so-and-so version of RESTful web services, so-and-so version of mail, so-and-so version of EJB container. And in your application server, you could have multiple versions of those running concurrently. You could pick and choose what application versions you want or implementation versions you want, and accordingly you'll bundle your application. It will continue to focus on OSGI interoperability. So, GlassFish, for example, already provides a modular application server, which is the modularity coming from the OSGI layer. Now, Jigsaw is going to define something which is a new modularity layer, but it will provide an interoperability with OSGI. And then finally, in the HTML5 tier, we will have all the standard APIs which are coming as part of HTML5. So, for example, a standard API to parse your JSON object and bind your JSON object, to do WebSockets, to do offline applications, to do caching, all of those APIs that are required to build your HTML5 applications. So that's sort of the big focus of Java EE 7 and beyond, actually. Now, it's a very logical step for Java EE going into the cloud. Because J2EE, as people call it as favorably, but it's mostly Java EE is the right terminology. Java EE has been offering services for many, many years. The deployment model is very well known. It's known to run bread and butter of a lot of different companies. The J2EE, Java EE platform has been offering these services. Offering platform as a service is a very logical step, wherein you say, what, I'm going to provision those services for you automatically. The key part over there is going to be an evolutionary change, in the sense it's not that we ask you to use completely new APIs. We will still continue to use Java EE 6 APIs. Java EE 7 will define how the deployment would be done in a cloud platform. And this, of course, is not restricted to public, private, or hybrid. Any mix is possible. So talking a little bit more about it, we will define new roles as part of Java EE 7 to accommodate Paas programming model. We talked about how service provisioning would work. The Java EE 7 container will automatically provision services, and in order to facilitate that, the Java EE 7 platform will define a services metadata. So now that services metadata could be either implicit, where a Java EE 7 container takes a look at your WAR file and derives the service metadata from it, or you could explicitly specify service metadata as part of your application to fine-tune the application. What would that service metadata consist of? Service provisioning and configuration. So for example, you could say, my application depends upon JavaDB so-and-so version, and it needs to be XA compatible. So Java EE 7 container will take a look at it. JavaDB, I know where that service is provisioned in my setup, and I will connect the dots for you. And as a convenience, I'll also create a JDBC resource for you, which you might need, or which you might have specified. For Elasticity, I could specify the constraints and the metrics I was talking about. My minimum number of servers in the cluster is 2, maximum is 8, so scale in and out between those using so-and-so metrics. Whether the database service that I was talking about, does it need to be initialized with each application deployment, or can it actually use a service that has been pre-provisioned and pre-initialized, thereby saving some deployment time for you? And of course, a reconfiguration and customization of application would be important, so that it just works every time. You don't have to bring down the app server or start the whole thing all over again. We're going to add a lot of new useful APIs as well after the metadata, which is like JAX-RS client API, which allows you to invoke a RESTful web service in a very seamless way, caching, state management, and JSON. And our existing APIs will also be extended to provide support for multi-tenancy. By that, what I mean is, think about when you're starting from a Java persistence API. You say, here is my POJO object, and I want to generate the database table from it. Or here is my database table, and I want to generate my JPA entity from it. What does it mean for a database table to be multi-tenant? Does your database table structure change? Does your JPA class structure change? What does it mean by your servlet session to be multi-tenant? Do I put a tenant ID in there? Is the tenant ID really injectable for me, or is it available to me? So things like that would be available. So, sorry, does that mean I have 30 more minutes or 30 minutes over? 30 more minutes.
30 more minutes.
Okay. So this is a quick rundown of what are the new roles that are available as part of the Java EE 7 platform. So the roles on the left-hand side are focused towards the developer. On the right-hand side are focused towards the Java E7 platform providers or Paas providers. So for example, developers are people like us who are going to build Java E7 applications. Now, even though there are multiple roles defined, but what that means is, depending upon the size of your company, the roles might be overlapping. So for example, a developer builds an application. A Paas customer could sign up with a Paas provider for an account, will maintain, maybe it has multiple accounts. A deployer would deploy the application, so on and so forth. Paas provider is who will provide the Paas service. Paas product provider would be a company like Oracle or IBM or Red Hat, which will actually provide a Java E7 compliant container, which would understand how to deploy a Java E7 application, so on and so forth. So let's take a look at what I was talking about earlier. The existing Java model is you provision and initialize database service, LDAP service, messaging service, application container, and then you eventually get down to deploying your application. The Java E7 model would be instead of provisioning and initializing all of those services, you would take your Java EE application and you will deploy it to a central service. For the lack of a better term, let's say cloud administration service. Okay, so you will take your Java EE application, deploy it to a cloud administration service, which would then understand either implicitly or explicitly specified as part of services metadata that I need to deploy all these services and provision them. Okay, so the cloud administration service in that case will automatically take care of provisioning and initializing these services from you. From your perspective, you just take the archive, the Java EE application, and you say, go ahead, deploy it to my cloud administration service, and all of this provisioning and initializing happens automatically for you. How does that implicit discovery actually happens? So today, for example, in Java E6, you could give an annotation like @data source definition. You could give the JDBC resource name here, the driver name here, some of the other properties of the database that you want. So this is one example by which the cloud administration service could actually discover the information that, oh, you possibly want a Oracle database, and let me create this JDBC resource for you. You want the initial pool size like 5. Now it becomes interesting when you actually have to start doing content negotiation. Oh, you are looking for Oracle database version 10.2, and I have 10.3. Should I do it? Not do it. So we believe that the containers will actually define some rules, either implicit or explicit, which will allow these content negotiations to actually work. The JMS specification is already defining these annotations, which would allow you to define, what these properties are going to look like and how the services can be implicitly initialized. Similarly, for a mail session, we are defining new annotations, and for the connector service as well. Now, in terms of the elasticity, as we talked about earlier, single node, is not good. It's a single point of failure right there itself. Today, what we're doing is Java EE multi-node, multi-instance clustering. So you have multiple instances scattered all across the cloud. You want to provide high availability, session failover capabilities, all of that. But if you want to add a new node, you literally have to provision a new node and then plug it in there. With Java E7, what we're getting towards is capacity on demand. So you want more capacity, there's a more demand for it, we will just boom, add a new server automatically for you. And you as a developer or as an administrator or as a deployer would define exactly when the scale up and the scale down should happen. So there will be like a monitoring dashboard which you could take a look at, which would allow you to handle those details. So if I can walk you through a scenario where a software company writes a simple application, they submit it to a Paas provider, they just want to go public, and they just want to say, hey, we want to expose this application in the cloud environment. Then their customers could sign up for the application and then start using it. So let's see how the whole scenario would look like, possibly. So let's say I have a traditional CRM company which is saying, okay, we want to go in the cloud. So they figure out a service offered by Diablo Cloud, just random names, no coincidence. Now, the Simply CRM company, the application developer, like us, we write an application, which is a traditional application, and I want to put this in a cloud environment now. So the Paas customer on the Simply CRM side would say, oh, you know what, I'm going to go and talk to the Diablo cloud. They possibly have a Paas account manager. So these two guys are going to talk. He's going to sign up, create an account, provide the account credentials, and the Paas customer on the Simply CRM side has the credentials now. Then there is possibly an application submitter. And remember, I said these roles could be overlapping depending upon the size of the company. But I'm just highlighting the roles that are defined by the Java EE 7 specification. So the application submitter then submits an application which is received by an administrator. He says, I'm going to deploy the application in my Diablo cloud. Now, extra services, which is a third-party company, sort of they want to go. They're looking for a CRM solution in the cloud. They find out about Diablo Cloud and the services offered by Simply CRM. So they discover the application. The Paas customer on the extra services sign up again with the Paas account manager. So they get their own app. Now the beauty of this is extra services is just one customer. There could be many such customers like that. And the application has the ability so that it can be customized. Maybe a customized look and feel, or the fields, or the UI, anything could be customized. So what the deployer on extra services do is, it actually starts working with the system administrator and add its own color to the application. So they really start customizing the application. Once the application is ready, it's actually provisioned on the cloud infrastructure and made available to extra services. So application is provisioned and deployed now. The customers of extra services now, they actually start using the application. And eventually the end users, the administrators can administer the application on the extra services side. And the system administrator on the Diablo cloud can actually monitor what the application looks like. The SLAs are being met or not. Are the scale up, scale downs happening properly or not? Those kind of things. Okay. So let me show you an application that I built for Java 1 last year. Okay, it's a traditional 3-tier Java EE 6 application. It's a pure Java EE 6 application. No application server dependent artifacts in here. No services metadata I was talking about. But the application is a conference planner application. So the idea is, for any conference, you need sessions, tracks, speakers, schedule, etc. So this application built using typical 3-tier JSF, EJB, and JPA allows you to track all of that information. And then attendees can register for the conference and actually sign up and build their own schedule. This application we will deploy to GlassFish, which is version 4.0, which is where all the Java EE 7 work is happening in the cloud. I'll talk about that cloud in a second. Optionally, my Java EE application could have services metadata. It's purposely meant not to be readable, so don't try to read it. But the idea is, you will have, this is an XML deployment descriptor, possibly would be an annotation as well. But this is where you would specify your services metadata. So if I have to highlight just one element over here, and all I'm saying here is max.cluster size value 4, min.cluster size value 2. So that's how you define your elasticity constraints. This is where you could possibly defining your metrics as well. This is where you could be defining what your triggers and alerts are. Okay. So let me show you this application then. So we talked about the cloud administration service. This is my Paas console, as we call it in GlassFish 4.0. So once I log into my Paas console, it will show me, it's a brand new installation of GlassFish, so no applications have been deployed so far. So I click on deploy. I say, okay, choose the application that I want to deploy. So I click on it. I go pick my WAR file here. And then at this point of time, my GlassFish Paas console is introspecting the WAR file. And it says, oh, by the way, this is a Java EE application. So I'm going to have some defaults, which is I'm going to make a highly available cluster for you automatically with a minimum of 2 instances and a maximum of 4 instances. And since this is a highly available cluster, I'm going to front end it with a load balancer as well. This is Apache load balancer, and I'll talk about that in a second when I show the script. But I'm going to have a load balancer front end this highly available cluster. And because you're using a persistence.xml, so you need a database as well. In persistence.xml, you're talking about a JDBC resource. So I'm going to create that JDBC resource, and I'm going to provision a database service for you. And it also provides a hook point for me, where this is what you can do to initialize your database. This is where you can run your DDL, or data description language, and DML, or data manipulation language. So create your tables and populate them. Okay. So then I click on choose file here. And I have multiple SQL files here, Java 1 and other conferences as well. So I pick one for Java 1, click on next, it confirms the values with me, and then I click on deploy. So it's going to go in the background and start provisioning those services for me. But if I have to explain it, so what's really happening here is, it's going to start provisioning my Java EE services. Oh, you said 2 is the minimum, so I'm going to provision 2 services, and I'll go with that. So 2 services are provisioned, and it's going to configure them in a highly available cluster. So that's taken care of. Then it's going to provision my database service, and in this case it's not a shared service. So with each deployment, my database is being provisioned. Then it's going to initialize my database. So my DDLs and my DMLs are getting loaded. And my load balancer is getting instantiated as well. So load balancer is being set up, everything local. Now all of this is done in a cloud. Cloud means a lot of things. But for us, the first one, the mode that I'm using is the laptop mode, or the native mode as we call it as. And what that means is all my services are provisioned on the local laptop. This is very quick and very easy for rapid development, debugging, and testing. Because all the services are local on my laptop, I don't need to be connected on the internet. I can just play around with it and see where it is. On the other hand, when you're going to production, your Paas administrator could possibly configure your GlassFish to run in a virtualized mode. By running in a virtualized mode, I mean using any virtualization technology. That could be Oracle virtualization, that could be VMware, that could be VirtualBox, that could be KVM, any of those virtualization technologies. And as a matter of fact, today we have a VMware plugin that is actually contributed by the community. So it's pretty cool. So now if I go back to my Paas console, it shows me that the application is deployed. I click on my application, and it shows that my load balancer is available at this URL. My conference planner application is deployed, a HTTP URL and a HTTP US URL, one for each instance. So one for instance 1 and one for instance 2. So that makes it 4. And here it shows me all the services that are available to me. So this is the load balancer URL. This is an endpoint URL. So let's say if I click on an endpoint URL, it's going to load the service for me. So literally what's happening is, with a single click, really, the entire service is being loaded for me. All the services are provisioned for me, and it shows me the data right over here itself. So now, it's a fully functional application. The emphasis is not on the application. The emphasis is really on how those services are automatically provisioned for you. So if I click on, say, for example, show speakers, it will actually query the database and bring me the list of speakers. Alright, so that was about the service provisioning part of it. Now in terms of multi-tenancy, there are different approaches that are still being discussed. Now in multi-tenancy, thinking from the database perspective, for example, when how do you basically expose tenants in your application? We could have one instance per tenant. That means the one application server instance per tenant, costly. Or in one instance, we could have multiple applications where one application is per tenant. That's another approach. Or another approach is where we could have one application and we could share the session where we provide the tenant ID as part of the call. So there are different approaches that are being discussed. The idea is to provide a consistent model across all the APIs. Now, each instance should be able to, each multi-tenant instance, so to say, should still be customizable and configurable to an extent. And the tenant ID itself will be available to the application, injectable as a JNDI name. So Java EE 7, even though cloud is the big theme, is not just cloudy. There are a lot more other things that are happening in Java EE 7. One of the big one is actually alignment between POJO, Managed Bean, and Enterprise Java Beans, specifically with CDI. All these specifications were introduced, and there are some inconsistencies between them. So we need to clarify how these components are going to work with each other very well. JAX RS API is getting a big revamp. So a lot of features coming in there. Client API, support for hypermedia where you can link the RESTful resources very well. Bean validation wherein you take an HTML form, submit it to a RESTful endpoint, and then your parameters are bound, the HTML form fields are bound to method parameters. How do you do field validation automatically? So that's Bean validation would give you that. JMS is finally getting a revamp after 9.5 years. Expanded use of dependency injection, and we talked about service metadata as well. Some of the specifications are going to be pruned. So how many people use JAX RPC today? Oh, wow. Okay. Just one warning for people who are still using JAX RPC. By the way, nothing against JAX RPC. I am from the original JAX RPC team. But it's no longer going to be supported in future versions of the application server. This is a quick preview of what the specifications look like today. Servlet 3.1 is getting a minor update, EJB 3.2 and JPA 2.1, JSF 2.2, Bean validation. These are all minor updates. JMS is a big one, from 1.1 to 2.0. JAX RS is 1.1 to 2.0. All of these are brand new JSRs that are getting included as part of the Java EE 7 platform. So I think I'm going to skip the details of each of the different specifications and jump here. Now all the Oracle-led JSRs, and actually even other community JSRs like the ones done by Red Hat and IBM, are done in a very transparent manner. As a matter of fact, that's exactly what Java Community Process is pitching for. So, for example, you can go to java.ee-spec.java.net, download the specification today. You can participate in the expert group today. You can look at all the traffic there. You can know exactly who the expert group members are. Their email IDs are actually made public. So you can talk to them one-on-one if you don't like posting in a public alias. That's very much possible. You can download the specification. You don't have to wait till an early draft or a public draft is made available. Things like that. Okay. In terms of status and schedule, all the JSRs that are scheduled to be part of Java EE 7 are up and running. There are lots of early drafts that are already available. So take a look at those on my blog. I've explained some of these specifications already on what does it really mean to write a JAX RS 2.0 application. So take a look at that. The final release is targeted towards Q2 2013. And the goal is it's going to be a date-driven release. So get it done by that time. Otherwise, move it on to Java EE 8. Now, under Oracle, we have done many releases of GlassFish. 2012, right? So 2010 March is when Sun and Oracle merger was completed. So it's over 2 years now. And since then, you can see 3.01, 3.1, 3.1.1, 1.2. We have done many releases of GlassFish under Oracle. 2013 is when GlassFish Server 4 is being planned. That's the focus for Java EE 7. And last but not the least, some pointers for you. This is the URL where you'll find everything latest and greatest about Java EE specifications, the reference implementation, and we update this blog on a regular basis. And I can take questions.
The OCI layer
Yeah.
that you comment is involved in the metadata configuration, or?
So now the question is, the OSGI layer is part of the metadata configuration. Now OSGI is an implementation detail today as part of GlassFish. So GlassFish is a modular application server built using OSGI modules. So you can take any OSGI bundle, deploy it in GlassFish, that will work.
It's
Only in GlassFish though.
in the development.
Right. Well, no, even in production.
Yeah.
And it's supported on GlassFish. But when Java EE 8 most likely will define modularity built on top of Jigsaw, Jigsaw will define, which is JDK 8 modularity, Jigsaw will define how it's going to work with OSGI. So once JDK defines, then we're going to build on top of JDK 8 as part of Java EE 8, and we'll just leverage that.
So right now we have the web XML file. So where would be a good place to start if we wanted to start using all these annotations for the data sources, GMS? Where would be a good place, like a configuration factory, something, or I don't see it in an application because the Pojo for configuring stuff, I don't know, I see it weird.
Yeah. Now, I'm glad you asked that question. I just finished reviewing an article by Adam Bean. I'm sure most of you guys know him. I just finished an article reviewing by Adam Bean. There exactly he talks about in Java EE 6 how would you do configuration. So instead of configuring in a deployment descriptor, which is what people have been used to, he exactly explains how you can use CDI, convention over configuration, right? So he exactly explains how you can configure your objects. He explains how you can have a Pojo object. You can define, for example, you can use produces clause to have your data source definitions, all the mail sessions being automatically injected. You can even define, for example, I am at the development stage of my product or development stage of my project, use so-and-so annotations, and at my testing stage of my project, inject so-and-so beans and things like that. So I think just stay tuned for that article. That would be really helpful.
Thank you.
Okay, if no more questions, I'm around here rest of the day. Oh, you have a question?
Yeah. The main thing of the Jigsaw architecture, modularity,
modularity, yeah.
Modularity is that in Jigsaw you can integrate the service, and you can do it. It can be easily expandable. It is the
expandable. Okay.
It's the main difference between Jigsaw modularity, as I could understand.
No difference between Jigsaw modularity and
normal. The last version of Java EE.
Right. So the big advantage of providing modularity in a Java EE application is, instead of taking a monolithic application server or a monolithic application, you could exactly define my application depends upon so-and-so components. So in a Java EE application server, for example, you could have multiple versions of RESTful web services, multiple versions of JPA, multiple versions of EJB container, and then in your Java EE application, you could say, I depend on version 2.1 of JAX-RS, 3.2 of EJB, and so on and so forth.
Wow.
So you have multiple versions running in parallel, and you can pick and choose the version that you care about.
Okay.
Right, I think we are out of time.
No, 5 minutes.
Oh, well, anyway, I'm going to be out in the hall. If you have any questions, talk to me. Thank you.